Okay, we are on to our fourth and final chassis for this customer out of Kansas City. This is a dedicated K7500 out of a Hydro Thunder. I think it was, or Arctic Thunder. Arctic or Hydro? I can never remember those stupid games. Well, he's got California Speed here listed on the troubleshooting sheet here. That's easy to say, troubleshooting sheet. No big deal, but doesn't matter what game it came out of. It's got color issues. And what I mean by that is that there's no blue. And you can see that it's, even though this looks very clean and not highly used, it is a very high hour, because you can see how burned that neck board is. Very common. But the previous owner did do a cap kit. Nice job on the cap kit. New flyback. Nice job on the flyback. I haven't taken it out and inspected the bottom, but anything that needs done, I'll take care of it. So it doesn't really need much work. Everything has been changed. I think this bipolar cap may have been overlooked, but I'll get that changed out with a newer one. No big deal. Anyway, it does work. I did turn it on and it's missing blue. So let's go ahead and show you here. This is a K7500. So with the 7500, we have to select medium res, and I have to use my test pattern generator here. So go ahead and turn it on, and let's fire this puppy up here. 1, 2, 3. Okay, it comes right on. Fantastic. It's always a good sign when that happens. And as you can see, well, this is yellow. I don't know if you can tell in the video. It comes across as white in the camera, but it's yellow. And if we just skip right to this, you can see no blue. But I'm telling you, I have not seen a K7500 that looks this outstanding in my life. It's absolutely unbelievable how crisp and clear this is. I have not seen anything this spectacular in quite a while. Medium res, that is. We just obviously did a very good rejuvenation video, but as far as this medium res 75, this looks absolutely phenomenal. Again, just like that first K7000, I wish this was mine. It looks so good. But it's missing blue, as we can see. And if we actually touch our, you can touch your heat sinks. A good way to know if you actually have a bad transistor is you can actually touch the heatsink. You won't get shocked. You may feel a little jingled, like a 9-volt battery on your tongue, but it won't hurt you. But if you touch it, not only can you feel if it's warm, but you can see as I touch the transistor, maybe you can't. It's hard to see on camera here, but you can kind of see how it changes a bit. It goes, the edge of the line here on the left will kind of go hazy a bit, and it's hard to see on camera, but in person it's very obvious. So I'm going to touch it right now. Either way, it's hard to tell. The red one, let's see. You can see the red here when I touch the red. How it's jumping a bit. There, you can kind of see what it's doing. The green will do that. All the colors will do that. It's hard to tell with the refresh here. But if we touch the blue transistor, not only do we not get anything, but it's not warm at all.
This son of a bitch is ice cold.
There's no heat coming off of it. It is absolutely ice cold. So yeah, we got heat from the green, heat from the red, heat from the green, nothing from the blue. So our blue transistor is most likely either open or we have bad solder joints. So we're going to do some inspection and some testing, see what we can find, but we're missing blue. It should be a very quick and easy fix. I have a U5000 on the way that also is missing blue, so that should be a good precursor, or this repair should be a good precursor to that one when that one arrives. And yeah, so it's ice cold, as we saw. And yeah, should be easy fix here. So let's get this turned around off the tube and see what we can find. Oh, so here we have the neck, and let's go ahead and give it a good look over, testing traces, testing the transistors, all that jazz. We'll see what we can find out and see if we can figure out why the blue transistor is cold. Whether it's reading open or shorted, or, well, it won't read shorted. If it was shorted, we'd have all blue screen. But whether it's open, or whether it's one of these other transistors, or these transistors over here, or a color pot, who knows? So let's go ahead. I have a suspicion that the transistor is actually just bad because it's cold. I mean, if it was hot and we were still missing blue, then I would suspect these transistors here, or these over here, or the diodes that are underneath here, or one of the resistors, or this chip, or I mean, it could be anything, but it's not, it's cold, what that means is that the transistor is not operating. Now, whether it's because it's bad internally, or it's missing, or it's got a bad trace, who knows, but let's see if we can figure it out. And we'll replace this transistor as a last ditch effort if nothing else pans out. So we can see that some work has been done because the green here is lifted, and the reason that we know that this is red, green, blue is not just because of what we just did by touching the case here and seeing that it kind of jiggle or wobble, but if you look here, we can see that we have red bias goes to red, green bias goes to green, blue bias goes to blue. So that's how we know this is the blue one, green one, and red one. It's very simple. So let's go ahead, and I want to reflow all this stuff. If we inspect this first, I guess we can look and see that it's very heat damaged. Very common though to see this, and I've got lifted pads and everything, again quite common. So but it appears to all be intact. So the first thing we want to do is just check to make sure we have good continuity. But I'm going to reflow these just to make it a bit easier to test, because these look a bit dull. I'm going to turn my fan on here. Why can't I push that one down? Interesting. Alright. I just did that because they didn't look very good. They weren't shiny and they looked a bit oxidized from the heat, so I wanted to do that just so we can get a better connection here for our testing. So we can turn the fan back off now. Okay. So we got continuity mode. If we hear the meter here. Hold on. There we go. So now let's test our continuity here. We know red and green are okay, but we'll test them anyway. Alright. Okay, now our blue. So we have good continuity. Let's test our actual transistor here. I think if we go from here to here, it's voltage drop. Let's get it in frame here if we can. Stupid light. There we go. I forget which way this goes. It only goes to one leg. There it is, okay. So that one's good. And it shouldn't read to the other one. It doesn't. Go to this one. And that's good. Shouldn't read to the other one. It doesn't. Alright, go to this one. What's this one going to read? Appears to read okay, but we know it's cold. So in that case, is it going to be this control transistor here? Because that control transistor is what feeds this one. So if we test that one, I do believe that if we read from the middle to each leg, it should be 0.6 to each leg. 0.7 and... maybe I'm wrong here. It depends on which way you read this here. 0.6 and... I think I had it right the other way. I think it's 0.7 and 1.0. That's how you read that. Okay, so this one's kind of all messed up here, but... 0.7 and 1.1, 0.7 and 1.0. Well, okay. None of that stuff appears to be bad. We can test our... These should be around 2.6. 2.6, so we know these are okay. 2.7 and 2.7. We can test the diodes under here. That's good. We know the green and red are okay. I'm just testing them anyway. Good. Good. So now the question is, we're going to have to test these 3 transistors here. So this tested good, but it's not getting hot, which means it's not being fed any power. So either it's not being fed any power, or internally it's open. But if it was internally open, we would have seen that when we tested it. So that's very odd. So I have seen this before. I think maybe a handful of times where it is not warming up, it is not working, but it still reads good. So I think we're going to probably end up just replacing this, and I'll bet it'll work. But we'll go ahead and check these transistors here. These 3 transistors are the inputs off of here, from the input through these, and then it goes over through here and then to this stuff. So if you're missing a color, it could be any of these 3 transistors as well. If all these check good and all these check good, you've replaced them all, they still have no color. If these check good, if your diodes check good, if these 3 transistors check good, if your pots are all good, the very kind of last step is this chip here, the 1203. So it's somewhat common for these to go out as well, but I don't think that's kind of a worst case, last case scenario. It's almost assuredly just simply a bad transistor. So the general way to do this is you just swap these. If you were to take this one out and put it in place of green, and put green in place of blue, and if you have red and blue and you lose green, then you know for a fact it's the transistor. It's a very easy test to do if you don't want to go to all this trouble. If you swap these and still have no blue, then you know it's one of these transistors or these or resistors or diodes or this chip. It's just an easier way to just swap these around to see if you gain a color or lose a color. But we'll test these 3 transistors as well here and just make sure. Okay, we'll start with the middle and go to each leg. 0.6 and 0.6. 0.6 and 0.6. 0.6 and 0.6. Well, okay. I think we simply have a bad transistor. So let me grab one, we'll change it out, and then we'll turn it on and see if it's the see if it's the transistor or not. If we change this out and it still have no blue, then I'm going to go after this chip right here. So let's grab a transistor, and we'll get it changed out and see what that does. All right, so I got my bag O 74, 75, 2000, 5000 parts. So let's grab, we got transistors and shutdown pots and Q703s and R303s and B plus pots and more R302s, vertical ICs, R104s, switch mode power supply chips, more B plus pots, R811s. Where the heck are my, did I not put them in the bag of parts? I got so much junk in here that where did my transistors go? I had a whole bag of them. Where'd they go? Well, what the heck happened to them? Are they in my... They're not in my K7000 bag. Well, that's disconcerting. I had a whole bunch of them. I'll find them. Hold on. Sorry about that. I found them here. For some reason, I had them in my bag of K7000 parts, not the 7400, 500, 2000, 5000 parts. So, all right, as suspected, I had them in the wrong bag. No big deal there. Okay. I need to get organized. This is, like I say, this is amateur hour. That's why it's the name of the channel. So I need to get an organizer and put all this stuff in organizers. But so I got a whole bunch of them here just for this occasion, and we're going to install these C3782. And as we can see here, where did it go? That's what these are. You can see there, 3782. So let's go ahead and just remove this blue transistor here. Oh, I gotta get my fan on. Oh, there we go. That was rather explosive. All right, so now we will soak up the solder here. I want to soak up solder. Be nice if you could see. Gonna get all the holes cleaned out. Alrighty. Do we have 3 open holes? We do, but I gotta get rid of the junk that's in there. What the heck? Get out of there. Someone's used super glue on these things and I can't get the hole opened up. There we go. Okay, and we'll bend our transistor up, bend our transistor leg out here and create ourselves a nice little install there. Put this one on there. Push that down a bit. Bend that away. It looks like someone has replaced all of these transistors as well, because those don't normally sit. Those aren't from the factory like that, and from the factory they're much further down. So I think someone's done a bit more work on this, trying to get this working, and that's why there was super glue in the holes and stuff like that. So, but there we have it. That's about where it needs to sit, just like that. And then we'll just solder it in place and call it good. And we'll test it again. I'm going to do a bit more reflow and clean up here. And then we'll test it. I want to get one leg soldered in here. Okay. That's pretty good right there. All right. Well, there we have it. Alright, so I'm going to go through and do a bit more cleanup and maintenance on this, a bit more reflow, and then we'll go ahead and get this, because I want to get this readjusted back down from sticking up like that. And then I'll come back and show all that off, and then we'll get it hooked up and see what we get. So stand by for a moment here. Alright, so all the work is now done. Everything is evenly spaced and set properly, and we're not inducing heat onto these resistors. You don't want them bunched together, you want them spread apart, because you don't want this resistor to induce heat onto this one and makes them burn out prematurely. So I got all of the transistors here lined up and even, and I got the back cleaned up, and someone definitely has reworked this because I verified they used some type of glue or epoxy underneath these traces to keep them from lifting again. And that's great, but they don't quite sit flat. When they did the work, they didn't push them flat before it dried, and they set up a bit higher, but it doesn't matter. We checked continuity, we checked all of these transistors, we checked these transistors, we checked all of these. Even though this one checked good, we changed it out anyway because it was cold. So I think internally it was open or bad. If we still have no blue, then I'm going to go after this 1203 chip here. So let's hook it up and see. But before we do, I just want to show some comparative readings here on, this is the one that we removed that we suspect is bad. This is a brand new one. And if we test these, I just want to do some show and tell here. Stay right there. Okay, so if we go to the center and we touch the right leg on our diode mode, should be nothing. We touch our left leg, oh, hold on there. See, nothing. Now if I touch the left leg, there's our voltage drop. Now here's the one that was bad we just took out of here from the blue. If we touch the right leg, nothing. Left leg, voltage drop. So it reads good. It tests good in circuit and it tests good out of circuit. Get out of there. So it tests good in circuit and out of circuit. It tests good, but it was cold. It was not heating up, not working. So I just wanted to make a show and tell here that even if it does test good in circuit and out of circuit, the heat test is always a good reliability. I meant to say reliability and ended up saying reliable. It's a good reliability test for whether or not the transistor is actually functioning. So even though it tests good, it can still be bad. And evidence of that is the fact that we A, had no blue, B, it was cold, and when I touched these two, you could see it kind of wobble a bit, and this one did nothing because we had no blue. So, you know, it's a mixed bag. There could be so many different things causing no color, but the most common and easiest thing for it to be is a bad transistor. And like I say, you can just swap these, whatever it is, whatever color you're missing, red, green, or blue, swap a working transistor into that spot. And if you gain your color back, the transistor is the original transistor in that spot is bad. If you don't gain the color back, then you got other things to look at, which I've already talked about. So let's hook it back up and see if we have gained our blue back. If we do, like I say, even though that this tests good in circuit and out circuit, the fact that it was cold means it's internally not functioning. So let's hook it up, see what we get, and cross our fingers, and I'll bet you that it'll work. If not, we'll go after this chip here. So let's see. Well, the neck board is now reinstalled successfully, all back together. I got the test pattern generator here hooked up, so let's go ahead and turn it on. We're set to medium resolution. So let's see if we get our blue back. Let's find out. 1, 2, 3. All right, comes right on. Always a good sign. Oh, my sync connection is bad here. There we go. I can already tell you that we do. Look at that. Glorious. Outstanding. So there's a good example of, even if the transistor checks good in and out of circuit, the fact that it's cold means that it's not working. And there you go. Now if we were to touch our blue here, I don't know if you can even really tell. Yeah, you're not going to be able to tell on camera here. Yeah, a little bit. See how the little haze comes up? You see it shifting around there? It's hard to tell. Touch it, touch it, touch it. So, yeah, there's the blue and the green. Either way, so, yep, now it's nice and warm. So, there you go, a good example of what to test and how to test these color issues on these series of chassis here. But man, this just looks so freaking good. It's just incredible. Wow. Okay, well, it's repaired. I'm going to take this off and go through and do an inspection, maybe some reflow if need be. I'm going to change that bipolar cap out to a better one. And then we'll call this 4 for 4 on these repairs for this person out of Kansas City. I can't obviously do a 4-hour burn-in on this with the test pattern generator, so I'm going to use my I have a spare Cruisin' USA board that someone kindly donated to me. I'm going to use that for my testing. But as we can see, we got all of our color back. let's go back to our color bars here for a moment. There we go. I mean, that just looks so good. Amazing. It's a bit too bright, though. That's better. Wow. Outstanding. So, all right. Another successful repair. Thanks for watching. Hopefully you learned something here about what's going on. And stay tuned. I need to get back to my other box of 16 chassis. I think I've got 2 of them down. I got 14 more to go. Plus I've got 1, 2, 3, 4, 5 of my personal ones to get to. Those need repairs. So I got sitting over here, well, I'll just show you here. Sitting over here, I've got 14 more over here to do, and I think 6 of them here and out of there to do. So no end to content here in sight. So stay tuned, and all of this stuff will get worked through eventually. Lots of stuff on the way, and of course I'll be working on stuff in between for people as well. So we'll see how all that goes. I appreciate it, and thanks for watching.